Welcome to this in-depth session on HDFS configuration and tuning. In this presentation, we will explore the key configuration files that govern Hadoop's behavior, specifically core-site.xml, hdfs-site.xml, and yarn-site.xml. We will discuss essential parameters, recommended best practices, and performance tuning techniques to optimize your Hadoop cluster. Let's begin by understanding the foundational configuration files and their purpose. Hadoop configuration is primarily managed through three critical XML files. First, core-site.xml defines global settings, including input/output behavior, remote procedure calls, and security policies such as Kerberos. Second, hdfs-site.xml focuses on HDFS-specific configurations, including name node and data node settings, replication, and storage paths. Third, yarn-site.xml is responsible for managing Yarn, the yet another resource negotiator which oversees cluster resource allocation via Resource Manager and Node Manager. These configuration files are typically located in the Hadoop configuration directory, which is $hadoop home/etc/hadoop. Let's now examine the core-site.xml file in detail. The parameter fs, default fs, specifies the default file system URI, typically set to something like hdfs//ninode host 8020. The EO file buffer size parameter should be configured to 128 kilobytes or higher when working with large datasets to enhance I/O performance. The temporary working directory, defined by Hadoop TMP dir, should be mapped to high-performance disks such as SSD to reduce latency. To ensure connection reliability, set client connect max retries to a value like 30. Lastly, for secure production environments, set Hadoop security authentication to Kerberos. Now let's look at tuning recommendations for core-site.xml. For high-throughput workloads, set EO file buffer size between 128 and 256 kilobytes. Always assign Hadoop TMP dir to high-speed SSD or NVMe storage devices. For security, it is strongly advised to enable Kerberos for authentication and configure SSL encryption for secure data transmission within your Hadoop cluster. Shifting focus to HDFS-site.xml, here are the most critical parameters. DFS replication determines how many copies of each block are stored, choose 2 or 3 depending on data criticality. For large files, set dfs.blocksize to 256 or 512 megabytes. To support concurrency, set DFS namenode handler count between 50 and 100 for large clusters and DFS datanode handler count between 20 and 30. Use multiple local disks for DFS datanode data dir and configure DFS namenode name dir using RAID-1 or RAID-10 or even JBOD if appropriate. The default heartbeat interval for data nodes is 3 seconds, controlled by DFS heartbeat interval. For clusters storing more than 1 terabyte of data, increase DFS block size to 256 or 512 megabytes to reduce metadata load. Ensure that each data node has 10 or more high-performance disks configured in DFS datanode data dir. To maximize fault tolerance and service continuity, enable namenode high availability, often abbreviated as HA. These optimizations enhance both resilience and throughput of the HDFS layer. Now let's examine key resource parameters in yarn-site.xml. Set yarn resource manager hostname explicitly to the resource manager's hostname. Allocate approximately 90% of physical memory to yarn node manager resource memory MB. Reserve 1 or 2 CPU cores for system processes and assign the remaining to yarn node manager resource CPU vcores. To find yarn, schedule a minimum allocation MB and maximum allocation MB to control container size flexibility. Enable MapReduce shuffle services via yarn node manager org services. Finally, the yarn node manager vmem-pmem ratio should be tuned to 4.0 for balanced virtual and physical memory usage. To avoid overcommitting memory, calculate yarn memory availability after subtracting what is reserved by the operating system and Hadoop daemons. For instance, in a node with 128 GB of RAM, allocate around 115 GB to yarn. If your workloads require, consider disabling the virtual memory check using the property yarn node manager vmem check enabled and setting its value to false. This is particularly useful for memory-intensive applications that might otherwise be rejected. Here are the best practices and performance tuning recommendations. Allocate 1 GB of heap memory per 1 million HDFS blocks for the name node. Use RAID-1 or RAID-10 for name node disks to protect critical metadata. Equip data nodes with 10 to 12 JBOD disks for optimal throughput. Use high-speed networks, preferably 10 gigabit Ethernet or more with bonded network interface cards. Tune the GVM using the GON garbage collector and consider setting Roman 20, plus use GON GC in Roman 20 max GC pos millis equals 200 for balanced performance. Enable Kerberos, TLS or SSL and data encryption to secure your environment. Finally, monitor RPCQ's heap utilization and disk I/O actively for early detection of bottlenecks. After configuration, it's crucial to validate and benchmark your setup. Use the command hdfs-site.xml report to check HDFS status and yarn node list to view active nodes. For benchmarking, the TestDFSIO utility is a standard approach. Run it with 10 files of 1 GB each to simulate realistic load. For troubleshooting, review name node logs under $hadoop/logs and yarn application logs using the command yarn logs application ID. Regular validation helps maintain stability and peak performance. In closing, always backup and version control your XML configuration files. Apply changes using rolling restarts to avoid service disruptions. For detailed parameter descriptions and advanced tuning, refer to the Apache Hadoop 3.36 configuration reference. An optional architectural overview is available at the provided shortened link https://tunnel.com/hadoop-arch. Thank you for following this session on HDFS configuration and tuning.